Okay, we're going to talk about a couple things today. The first thing we're going to talk about is the combination. Well, it's all about the combinations of functions, but the first combination we're going to work with, there's four altogether: adding, subtracting, multiplying, and dividing functions. Okay. The next thing we will talk about is the composition of functions. So that's something that you saw a little bit in your summer homework, f of g of x, g of f of x. But we're also going to talk about the domain of those functions. Okay, so those are the two objectives that we're going to cover today and that your homework will cover tonight. Okay, so let's first talk about the adding, subtracting, and multiplying and dividing. First of all, if you're going to combine two functions, they need to have overlapping domains. Okay, what does that mean? If one function has a domain of 3 to infinity and another function has a domain of -3 to -infinity, okay, those don't overlap anywhere. We can't actually combine them at all. We have to have overlapping domains so we can combine those parts of the overlapping domains. Okay, typically we're not going to have too much of a problem. We're going to work a lot with polynomials. We'll see a couple like square root functions or rational functions, but a majority of the functions that we will combine are polynomials. Okay, so if we want to combine functions that have overlapping domains, we can add them together. Okay, the biggest thing here, I want you to look at the notation. Okay, this f plus g of x just means take f and add it to g. The difference, just want you to look at the notation. F minus g of x just means take f of x and subtract g of x. Product, multiplication, f times g of x just means take f of x, multiply to g of x. And last but not least, the quotient. F over g of x just means take f and divide it by g. Now I have that g of x can't equal 0. Why must we write that? Why must we think about that? What's important there?
It'll be undefined.
Okay, we can't divide by 0. All right, so whatever is in the denominator, we just need to make sure that it can't equal 0. Okay. So we're going to do some examples. All right. This is something that you've done before, whether you've done it before or not. These four combinations of functions, they go pretty smoothly. Okay, they're not. Hopefully, they're not too much to think about. Okay, so here are our two functions. Please write them down. We have f of x is 2x minus 5, and g of x is 2 minus x. What kind of functions are both of these? Linear functions. Okay. What is the domain of 2x minus 5? Okay. Negative infinity to infinity. What's the domain of 2 minus x? Also negative infinity to infinity, okay? So since these two have overlapping domains everywhere, we can combine these functions. All right, so let's start with the sum. I want to find f plus g of x. All we have to do is take f, 2x minus 5, and add it to g, 2 minus x. What is the sum of these two functions? You agree? X minus 3? Great. And what's the domain of the result? Also negative infinity to infinity. Awesome. Okay. The difference of functions. So we want f minus g of x. Here's where we need to be careful. We have our function f, and we are going to subtract our function g. What should I do with g to ensure that we subtract the whole thing? Okay, you can either take a negative through, or you put it in parentheses so you don't forget to take that subtraction all the way through. Okay. This is something that a lot of us, not a lot of us, but there was a handful of us that got number 10C wrong because we forgot those parentheses. Okay, make sure you're subtracting the whole thing. So what do we actually get as a difference? Three x minus 7. Okay, what's the domain of 3x minus 7? Negative infinity to infinity. All right. The product. F times g of x. Okay. Here, since we're multiplying, we need to make sure that both of them get in parentheses. So 2x minus 5 is going to be multiplied to 2 minus x. Okay. And what's our strategy going to be here? Okay, FOIL. You can say FOIL, or you can say distribution. Everybody in the first has to be multiplied to everybody in the second. So let's go for it. 2x times 2. 2x times negative x. Negative 5 times 2. And negative 5 times negative x. Okay. I like your, if it is a polynomial, I like your polynomial to be in order based on the degree of your variable. So what value do I want you to write first? Negative 2x squared, then plus 9x, and then minus 10. Okay. Our resulting function is what kind of function?
Quadratic.
Quadratic, thank you. What is the domain of any quadratic? Negative infinity to positive infinity. Very good. Last but not least, we're going to look at the quotients. Okay, so we're going to take our function f and divide it by our function g. Can we simplify that any more? Sorry. Can we simplify that any further? We cannot. Okay? We can only cancel out if we have common factors. So if we could factor something out of these that was the same, we could cancel them. All right? Because things have to be separated by multiplication for us to be able to divide out. All right? So there are no factors in common. We have to leave it as is. However, let's talk about the domain. What is one thing that we have to look for when we have a fraction? What did I say was not allowed? Okay, we cannot have a 0 on the bottom. What would make this denominator 0? 2. So our domain has to be everything except 2. All right, so how do we write that? We can have anything from negative infinity to negative 2 up to negative 2, and we can have anything from negative 2 and beyond. So that's how we would write the domain of that function. Everything except 2, negative 2. 2. Why am I writing negative 2? Thank you. Everything except 2. Okay. So 2's in parentheses, it's not included. We have everything up to 2 and everything after 2.
Is that the same for like writing domain for like reciprocal functions? Because they never like hit 0?
Yeah. Very good. So that may help you on your parent function chart. Right, Kyler?
That's right.
Okay. All right. So this should be the easy part of your assignment. Okay. I would not call the next portion difficult, okay, but there's just a little bit more work to it, okay? We didn't have to do a really whole lot of work for doing, okay? And nobody's complaining, right? You guys need to wake up. It's 8:20, you should be more awake. Your school starts at 8:20, you should be more awake on Wednesdays, right?
20 minutes.
Okay. So, first of all, we're talking about a composition. I don't know if you have seen this notation or not because I don't know what you're exposed to in Algebra 2. Have you seen this little circle before? Okay, excellent. Welcome to Honors Pre-Calculus. Here's a new notation for you. So you've seen this f of g of x, right? You've seen this composition. This means the same thing. F, open circle g, means f composed with g. Now, we have to be careful with our domain. Okay? So the domain of f composed with g. So we're taking x's and we're plugging them into g, and then we're plugging g of x into our function f. So we have a couple of domains we need to think about. Okay? First of all, our domain needs to be able to, well, we're going to have a domain for g. So whatever we can plug into g is what we're starting with, right? These values also have to be plugged into the composition. So we plug values in for g, and then those outputs get plugged into f. So when we look at the domain, we are going to look at where the domain of g is overlapping with the domain of our result from the composition. Okay. So I'll let you kind of write down what you need to, and I'll say that again. Okay, so when we start our composition, we start out with whatever is in the middle, okay? We start from the most inside and work our way out. So g of x is going to have a domain. So the x's that get plugged into g, we're starting out with the domain of g. Okay? If our domain is 0 to infinity, okay, then at most our composition can have a domain of 0 to infinity, okay? Our domain cannot get bigger, all right? It can only start where G is and either stay the same or get smaller, okay? We are going to have an equation here where we can look at the domain of this equation. And where these two overlap is what the domain of our composition will actually be. So we're going to get an algebraic expression for F composed with G, all right? Sometimes it will be one that would have a larger domain, okay? But if we're starting with a domain that's already restricted, we can't make it bigger once we get inside the function, okay? So we have to look at where our domain of G overlaps with the equation we get as our result. And when we do an example, I'm hoping that it will make a little bit more sense. I know I'm kind of just talking right now, all right? So let's do a couple examples and see what that looks like, okay? So here we go. We are going to do F composed with G. Please write down these two functions. F of x is x squared minus 9. G of x is 9 minus x squared. Okay. So let's find, well, first of all, these need to have overlapping domains for us to be able to combine them. So first of all, what is the domain of F? We have x squared minus 9. Okay, so the domain here is negative infinity to positive infinity. All right? How about the domain of G?
0 to positive infinity?
Well, we have to be careful because this is 9 minus x squared underneath it here. So we can't think of transformations because this isn't the parent function. Let's think about numbers we can plug in, okay? What is not okay to have under the radical? Negatives are not okay. Is 0 okay? Okay. So what would make that radical 0? 3 would make it 0, or negative 3 would also make it 0, right? Okay. So what values, 3 makes it 0 and negative 3 makes it 0. What numbers, what kind of numbers would make that, would cause this whole radical to be negative? Like what would x squared have to be to make 9 minus x squared negative? Okay, if we plug in negative 4, negative 5, negative 6, that's going to make that negative. If we plug in 4, 5, 6, that's going to make it negative. So only numbers between negative 3 and 3 are safe. Right? Okay. So we have overlapping domains. We are safe. So let's talk about the composition. So remember, F composed with G just means we're taking F of G of X. Okay. What does this mean? We're going to take G of X and we're going to plug it in wherever there's an X in our F function. So instead of x squared minus 9, we have the square root of 9 minus x squared minus 9. Okay? If you need to actually write x squared minus 9 and erase the x and replace it with whatever you need to, that's fine. Yes?
If the domains don't overlap, then like can you just not do the composition?
Yes, basically. All right, so what happens to, what happens with our algebra here?
Square under the square root.
Okay, square root and square can cancel, so we have 9 minus x squared minus 9, which would leave us with negative x squared. Okay. Now, what would the domain be if we just had negative x squared? What's the domain of negative x squared? Okay, this is a parabola, so our domain is negative infinity to positive infinity. However, we got negative x squared from the composition. So we started by plugging in values to g of x before we plugged them into f. So we need to think about what the domain is for g of x. Okay. Well, we decided the domain for g of x was negative 3 to 3. Okay, so we started with a domain of negative 3 to 3, and we ended up with a function that could have all real numbers, but the domain of our composition can only be where these two overlap. Okay, so yes, negative x squared has a domain of all real numbers, but we started out by plugging in numbers to a function that only can have x values from negative 3 to 3. And so we have to see, we can't plug values outside of g's domain into the composition. Okay, so you need to look at your resulting function and the function that is inside your composition and see where those domains overlap to identify the domain of your composition. Does that make sense? Okay, if we're plugging into G first and we have a restriction, we can't make that restriction bigger because we can't plug values into G that don't make sense. All right, so here is your homework assignment, and you actually are going to get some time in class to work. We're here for, like a good almost 10 minutes. And so you can go ahead and have some time to work in class. Here is your homework assignment. You will have a survey to fill out before you come to class tomorrow. This homework assignment should not take you very long, okay? It should be fairly quick, especially since those problems didn't take us very long and you don't have too many, okay? I also would like you to watch a short video on 1.9. Tomorrow we're going to talk about inverse functions. You have seen inverse functions before. And so the video covers all of the basics that you know from Algebra 2. That way tomorrow we can have time to do more in-depth examples that deal with more complicated equations and domain and range. Okay, you haven't really talked about domain and range with inverse functions, and I want to have a lot of time to discuss that tomorrow. Okay, so you have a short assignment with your survey, a short video, take notes on it if you need to. And then tomorrow I will collect your problem set number 1. Okay? If you need to turn it in today because you're afraid you're going to lose it by tomorrow, then feel free to put it in my turn-in box, but I'm collecting them tomorrow. Okay? Let me get this stopped here.